Hello and welcome back everyone to another physics guide. Today we're going to be looking at the multiple choice questions from the 2023 March Free State paper. Let's get started. Question 1.1. A suitcase is at rest on a table. Which one of the following is the reaction force to the weight of the suitcase as described by Newton's third law? So when we think about Newton's third law, we are thinking about action, reaction pairs. Right? And these objects are often in contact with each other. So we have to draw just a little table with a suitcase on top of it. The weight of the suitcase is causing the suitcase to exert a downward force on the table. Right? So the reaction force, let me just write it down. So the action would be the force of the suitcase on the table. So suitcase on table. If you want to get the reaction force, all you need to do is switch the words. So the reaction force would be the force of the table on the suitcase. And that answer is D. Question 1.2. If a horizontal force F is applied to a crate causing it to move over a rough horizontal surface, the kinetic friction between the crate and the surface on which it moves depends on what? Alright, so let's look at the equation that we can use to calculate friction. So friction is equal to mu k times Fn. Okay? So we can see that the friction depends on the normal force. So the greater the normal force, the greater the friction. So let's see which option that's going to match with. So A, the applied force, that's out. How fast the crate is moving? Nope. The upward force exerted by the surface on the crate. So they just worded it differently here. This is describing normal force. So C is our answer. Question 1.3. Object P exerts a gravitational force on object Q when the distance between their centers is r. The distance is now doubled. Which one of the following represents the gravitational force that P now exerts on Q? So we can do it quite simply. We can say that F is equal to G m1 m2 over r squared. But now with the change, the new force is going to be G m1 m2 over 2r all squared. Now most learners forget to square the 2, so be careful of that. So to simplify, G m1 m2 over 4r squared. We can take this 4 out as a fraction, so 1 over 4 G m1 m2 over r squared. We know that that is the same as F, so a quarter F. So in this case, our answer is going to be A. Question 1.4. An object of mass m moving at velocity v collides head-on with an object of mass 2m moving in the opposite direction at velocity v. Immediately after the collision, the smaller mass moves at velocity v in the opposite direction and the larger mass is brought to rest. Refer to a diagram below and importantly, ignore the effects of friction. So if they tell us to ignore friction, that means the system is isolated and it means that momentum is conserved. So we can take that as a clue. So immediately B and D are eliminated. Now we need to figure out the kinetic energy. So whether it's elastic or inelastic. So to do this, we'll work out the kinetic energy before and then we'll work out the kinetic energy after. And if it's the same, then it's going to be conserved. If it's not the same, it's not conserved. So the sum of the kinetic energy before. So let's do them separately. We'll say, let's label them. So that will be car A, that will be car B. This will be car A, that will be car B. right? So just we've labeled them just so it's easy. So for car A, we're going to say the EK is equal to half mv squared. And then for car B, the EK is going to equal half of 2m times v squared. Half of 2 is 1, so it's just going to be mv squared. So if we add them up, we're going to get half mv squared plus mv squared. That's 3 over 2 mv squared. So this is the sum of the kinetic energy before. So we can also do the sum of the kinetic energy after. For A, the EK is going to be half mv squared. For B, since it's not moving, it's going to be 0. That means the sum or the total is going to be half mv squared. We can see quite clearly that it's not the same. Before it was 3 over 2 mv squared, after it was half mv squared. So the kinetic energy was not conserved. So that's going to correspond with option C. Question 1.5. A ball is thrown vertically upward. Which one of the following physical quantities has a non-zero value at the instant the ball changes direction? So we know that if an object goes up, at some point it's going to stop. And at that point that it stops, the velocity is equal to 0. This is at the max height. So immediately, I think we can eliminate velocity because they're looking for the one that has a non-zero value. Velocity has a 0 value. Okay? Then let's look at momentum. To calculate momentum, we know that momentum is equal to m times v. And if velocity is 0, then momentum will be 0. So that's out. Then let's look at acceleration. Maybe we're unsure about acceleration. Let's leave it out and go to kinetic energy. To calculate kinetic energy, that's equal to half mv squared. As we said, at maximum height, velocity is 0, so kinetic energy will be 0. So D is out. So the only option left is C. And this is something also it will be beneficial to remember, that for any free-falling object, or an object that's in free fall, or a projectile, the acceleration is always going to be 9.8 meters per second squared down. Always. Okay, question 1.6. A ball is released from rest from a certain height above the floor and bounces off the floor a number of times. The position time graph represents the motion of the ball bouncing from the instant it is released from rest. When ignoring air resistance, which point A, B, C, or D on the graph represents the position time coordinate of the maximum height reached by the ball after the second bounce? Now, this graph is a little tricky to interpret the way it is now. So what we can do with a position time graph especially is if we change the direction as the direction that's positive. So if we change the direction that's positive, we basically reflecting the graph on the x-axis. On the x-axis. So what I'm trying to say is, if it's difficult to interpret like this, simply reflect the graph and then the graph will resemble the actual trajectory of the object. So, for example, if I reflect this, the graph will look something like this. This is going to be point A. That's going to be point C. That's going to be point B. That's going to be point D. So now it's easier to interpret because now it's following the trajectory. You can kind of picture the motion of this object. The object goes down, it hits the ground at point A. Then it bounces, it reaches point B, which is the maximum height. Then it hits the ground at point C, then it goes back up, reaches maximum height. So they want to know after the second bounce. So this is the first bounce, that's the second bounce. After the second bounce, the maximum height it reaches is d. So the answer is D. Let's move on. Question 1.7. Which one of the following momentum versus time graphs represents the motion of an object that starts from rest and moves in a straight line under the influence of a constant net force? So if an object has a constant net force, we know F net equals ma, right? So a constant net force means a constant acceleration. It's going to be accelerating constantly. And what does that mean? It means that the velocity is going to be increasing, right? If a vehicle is accelerating, it means that after every second or every millisecond, whatever time interval, its velocity is going to be increasing, right? And since we know that momentum is equal to m times v, if the velocity is increasing, it means that the momentum is going to increase as well. So the answer here is going to be D. Question 1.8. Impulse is equal to, so let's look at the equation. Impulse is equal to F net times delta t, and that is equal to delta p. So impulse is equal to the final momentum? No. Impulse is equal to the initial? No. Impulse is equal to the change. So this delta, that means the change. So impulse is the change in momentum of a body. So the answer is C. Question 1.9 and question 1.10 were repeated in another paper. Copy paste exactly the same. So I will link it above.